So chapter 3 is all about graphing. So before we can really talk about actually going about and graphing things, we just need to do like a big information dump here in the beginning about some of the criteria that we have and some of the descriptors we have for these functions and some key features that we're going to be interested and all that kind of good stuff to start with. So this first section we won't actually be doing any graphing. We're just going to be learning about some of the characteristics of these graphs. And the graphs that we're talking about are sine and cosines. So if I take the class of all sine functions, the parent function for the class of all sine functions is y equals sine x. Remember what we mean by parent function? It's like the simplest version of that particular class of functions. So let's take a look at what this graph looks like on our calculator. So I'm just going to go to the y equals menu. I'm going to press sine of x. And then I'm going to go ahead and check my mode. So typically when graphing, we're going to graph things in radian mode. So I'm going to make sure my calculator is in radian mode. And then I'm going to press zoom. And then I'm going to pick the function or the option, z trig. So that's going to pick a window that's appropriate for most trigonometric situations. I might have to adjust a little bit, but by and large, that's a good one to do, especially if we're not given any other specific instructions about how to view the function. Okay with that? So radian mode, first and foremost. If you tried to graph this in degree mode, you're probably just going to get something that looks like a straight line. And then the zoom trig option usually gives us a pretty good picture. All right. So if I want to talk about the domain for sine of x, in the previous chapter, we developed the point definition for sine, cosine, tangent, etc., so that we can take the sine of any angle, right? Positives, negatives, whatever, doesn't matter how big or how small, we have a way to do that. What that means is that my domain is going to be all real numbers, because I can take the sine of any angle I want. If I look at the graph, though, the range is definitely not all real numbers. It appears that there is some minimum value and some maximum value to my function, right? So if I look at the y-coordinate, it looks like the minimum value is at -1. And then if I look at the maximum value, it appears to be +1. Does everybody agree with that? So that turns out to be the case. Note that I'm using a bracket there, not a parenthesis. So what if we want to talk about the symmetry for this function? So if I look at this graph, it looks like there's some kind of symmetry here, right? If I focus just on the left half of the graph, if I flipped it across the x-axis, and then flipped it also across the y-axis right after that, it would look exactly like the other half of the graph, right? Can you visualize that in your head? That's called 180-degree rotational symmetry about the origin, which is a mouthful. Really what we're going to do is we're going to call all functions that have that kind of symmetry, we can call them odd functions. you guys see, let's talk about continuity next. Do you see any vertical asymptotes here? No. Do you see any holes in the graph? No. Do you see any jump discontinuity? No. And in fact, none of those things exist, so this is everywhere continuous. And now I'm going to list 3 terms that we haven't defined yet. We're going to just define them in just one hot minute. So I'm just going to write them down and write down the value of them for the sine graph afterwards. And then we'll talk about what they mean here. So the amplitude is 1, the midline is y equals 0, the period is 2 pi, and the frequency is 1 over 2 pi. Trig. So let's just try to define these 4 terms, and that's probably as far as we're going to get today. We'll pick up where we left off next time. So the amplitude is half the total height for the wave. So if I look at the total height, it's going from -1 all the way up to +1. So the total height is 2. When I divide that in half, I get 1, which is what we said the amplitude was. The midline is the average value, or y-coordinate, for the function. What average value really means is that basically like half the graph is above this line and half the graph would be below this line. So if we look at y equals 0, which is the same as the x-axis, looks like about half the graph is above and an equal part is below, right? That's what we mean by a midline. There's equal parts above and below whatever that horizontal line that we're drawing in is. So we can find that by taking y max plus y min and dividing it by 2. Like literally the average formula, right? We're just averaging the y-coordinates. The period is the length of one full cycle. So for us, a full cycle is going to be an up and then a down. Everybody okay with that? So if I look here, we're starting at 0. We're doing our up, doing our down, and then we're ending here. If I count it along the x-axis, that is starting at 0 and ending at 2 pi. And then the frequency is the number of cycles per 1 unit interval. Basically, what I want to remember here is that the frequency and the period are related because they are reciprocals. So that's probably the more important way of thinking about that. We'll stop here because bell's going to ring in just a moment, and I was able to finish those 4 definitions, so I'm pretty happy about